Good morning and welcome to Algebra 1. So today we're going to look at what impact outliers have on our measures of center, called the mean and the median. To begin, I'm going to give you 5 nice easy numbers. They're the numbers 1, 2, 3, 4, and 5. And I want you to tell me the mean and the median. Well, the mean is found by adding up all the numbers and dividing by the number of numbers. 1 plus 2 plus 3 plus 4 plus 5 is 1, 3, 6, 10, 15. And there's 1, 2, 3, 4, 5 numbers, so it's 15 divided by 5, which is the number 3. So far, so good. Now, the median is the middle of ordered data, so 1, 5, 2, 4, there's the number 3 right there. So the median is also 3. When we have what's called a symmetric distribution, which means the numbers are equally spaced to all sides of the center, this will be true. We have the same number as the mean and the median. Now, I'm going to change something about our distribution, and we're going to see what effect it has. Let's just say, I'll use a different color to make it a little clearer. So with red, let's say we change that 5. I'm going to change it up a little bit. I don't think it's a 5. Maybe it was a typo, and it was supposed to be the number 50. So I'm just going to, fix that problem right there. That's supposed to be a 50. Clearly, the number 50 is a lot higher than all the other points. A lot higher. So it's pretty much guaranteed to be an outlier because it's so far away from the rest of the data. What is the effect that that number has on our data? Well, let's refigure our mean. I'm going to just add up again. 1 and 2 is 3, and 3 is 6, and 4 is 10, and 50 is 60. There's still 5 numbers, so it's 60 divided by 5. It's 12. The mean jumped up to 12. It was 3, now it's 12. It moved up a lot because that outlier had a strong impact on the mean. Let's refigure the median also. Maybe it's also 12. Let's see, the median, we're going to count in. So 150, 2, 4, it's still 3. The median didn't care at all that the outlier was there. It had no bearing on the median because the outlier, the high number, is still the high number. 5 was the high number before. 50 is the high number now. I could have made that 5 million. It still would have had the same median of 3. See, the mean is heavily affected by outliers. We say it's not resistant. It can't resist the pull of outliers. If there's a high outlier, the mean's going to shoot up. If there's a low outlier, the mean's going to shoot down. But the median doesn't really care. So the median is what we call resistant. It doesn't care about the presence of outliers. It only cares that there is a high number or there is a low number. Whether it's exceptionally high or low, it doesn't matter to the median, just that there is one. So exceptional outliers affect the mean greatly. Not so much with the median. What happens in another distribution when we just remove outliers? That's the next question. So I'm going to give you a new distribution. Ready? We'll say 60, 65, 70, and 1,000. All right, so right now I want to find the mean and the median of the current distribution, recognizing that the number 1,000 is way high above the rest of those numbers. So to find the mean, once again, we're going to add the numbers together and then divide by the number of terms. Well, let's see. What is 60 and 65 and 70 and 1,000 all added together? That's 1195. There's 4 numbers there, so I'm going to divide it by 4. That is 298.75. Okay, and the median Well, the median of 4 numbers is going to be in between the middle two. So what's between 65 and 70? Well, you can find their average. 65 plus 70 over 2 is the average of those two numbers. It's 67.5. So the first thing I want you to understand is that right now the median is a better representation of center because most of the points aren't anywhere near as high as the 1,000. The median is 67.5, which is more in keeping with those data points. But the 1,000 had a pretty strong impact on the mean. Our mean is 298.75. Really, really affected the mean. What if we say, I don't like the number 1,000. There's a reason why we're going to get rid of it. It was a mistake. It was my cat jumped on the keyboard and I got an extra 1,000 in there somehow. I don't want that. So we're just going to get rid of it. Okay, the 1,000's gone. It was a mistake. So what's my new mean? Well, without that extra 1,000, my new mean is just 60 plus 65 plus 70, which is 195. And there's only 3 numbers now. So I have to divide 195 by 3. 195 divided by 3 is 65. 65 is our new mean. The median, I got to find the new median also. Now this time there will be a change because I didn't just change the number 1,000. I just ditched it entirely. So now the median is just the middle of these 3 numbers, and it's the number 65 also. Now the median changed a little bit. It had to this time because we dropped one of our numbers. We didn't change it. We got rid of it. It's a different effect. So the median moved a little bit, but what was the effect? If I drop the large outlier, the high outlier, my mean went all the way down to 65 from almost 300. My mean decreased because I lost a high outlier. The median also decreased a little bit. When I drop a high outlier, the mean decreases. That's an important thing to remember because when we do our assignment today, it's pretty much all the assignment's about. So if you, let's say if you drop a high outlier, the mean decreases, which means it goes down in value. What happens if you drop a low outlier? What if there was a low number and we dropped it? I'm going to put the sentence here, drop low outlier, mean. Well, before I finish that sentence, let's have an example, okay? Quick example. 1, which will be our low outlier, and then 20, 23, 25. Just nice and easy, okay? 4 numbers. What's the mean right now? With that low number of 1, it's pretty low right now compared to the others. What do we have when we add them together? Well, we have 21 and 20, 23 and 25. Okay, so when you add them together, all right, we get a total of 69 over 4. Going to divide that by 4, 17 and a quarter. So that's the mean right now. What if I got rid of that number 1? Let's say, again, it was a mistake. It was done in error. We don't want it. It should go away. If I get rid of it, then the new sum is 68, but it's only divided by 3. So what happens if I divide 68 by 3? I get 22.6 repeating. By dropping the low outlier, what was the effect on the mean? It went from 17 and a quarter to 22 and 2/3. So by dropping the low outlier, the mean increased. So the word that's missing in my definition right now is the word increases. So dropping a low outlier, the mean increases, goes up. Okay, we call that the effect of removing an outlier. So remember again, the mean is not resistant. It doesn't resist the pull of the outlier. So if there's a high value, the mean's going to go towards it. But when you get rid of that high value, the mean's going to come back down. If there was a low value, the mean is going to shrink towards it. But if you get rid of the low value, the mean's going to come back up. So why do we go over this? Well, because the task of the day is an IXL, which is all about the effect of removing an outlier. So you're doing IXL. It's an easy one. Trust me on this one. It's Algebra 1, as usual. The task is KK.5, and I'd like you to get to 90%. It shouldn't be too hard. These are fairly straightforward questions. You don't even have to calculate the outliers. You just have to recognize which ones are exceptionally different and identify it, and then say what the effect would be of getting rid of it. So let's say you have it, every number is in the hundreds, and then you see the number 3. You're going to click on the number 3 because it's clearly not belonging to the rest of the data. The effect of removing it, well, 3 is a low outlier, so the mean will go up. That's the entire IXL task, all right? Get to 100, you get extra credit. Get above a 90, you get extra credit. The task is to do that right now. You should have plenty of time right now, so there shouldn't be any need for weekend homework or concern of what to do because it's the holiday weekend. All you have to do is get to 90% right now on IXL Algebra 1 KK.5. Shouldn't take too long. Let me know if there's any problems. Either join the meet or send me an email, and I'll be there to help out. That's all for today. So that's it. Have a great day.